Welcome. This video on compound probabilities is brought to you by the Learning Center at Vancouver Community College. Visit our website at www.vcc.ca/tlc for more information. We're looking for requests, so please submit your suggestions to mathsciencetutor@vcc.ca. The question is, a box contains balls in 4 colors and 3 patterns according to the distribution shown at right. Always drawing with replacement and randomly, what is the probability of drawing each of the following? The basic formula for a simple probability is number of successes divided by number of possibilities. There are 9 successes, balls with blue, and 30 balls of any description, so the probability is 9/30, or 3/10, or 30%. There are 2 primary ways to put together simple probabilities to make more complicated problems. These are called compound probabilities. The first is an or probability. You can think of it as an or-else situation. For this question, you can draw a solid red, or else you can draw a spotted green for success. The question asks about either of 2 outcomes, but since it's only one draw, it's all talking about the same event. Since we are given 2 different ways to succeed, it's easier to get a success than drawing a solid red or a spotted green separately. This implies that the probability should increase. Anything that's easier gets a higher probability. Finally, because probabilities are fractions between 0 and 1, the way to combine individual probabilities to get a bigger answer is to add them. The answer to this new problem is not 16/30. Adding the purple to the striped balls counts these purple striped balls twice. It's possible to get both outcomes simultaneously. These outcomes are not disjoint. To correct the problem, we have to subtract the probability of getting the overlap, since it's the 2 purple striped balls that make up the overlap. The other way to combine probabilities is with and, though it can be more useful to think of and then. Draw a green ball and then draw a blue one. Here we have 2 distinct events, or things to check for, rather than a single event. It's harder to succeed in this question, since we might draw a green ball first, but not a blue ball second. There are more hoops to jump through. Because it's harder, we expect the compound probability to be lower than either of the individual outcomes probabilities. And because probabilities are fractions between 0 and 1, the way to combine individual probabilities to get a smaller answer is to multiply them. It's not always as simple as multiplying probabilities. We have to check whether an and probability is made from independent outcomes. Here the 2 draws are independent because the first has no effect on the other. If we were drawing without replacement, the odds would change with every ball we removed from the pool. If I draw a ball and I tell you that the ball I drew is red, does that change the probability that that ball is purple? Yes, since no balls are both red and purple. Those 2 events are therefore not independent events. You can use conditional probability to find a compound probability of this type, but it's often easier to find the answer directly. That's compound probabilities. If you'd like more detailed information and some practice problems, look for the Probability 2 worksheet for Math 0993 and Statistics courses on our website, www.vcc.ca/tlc.